Welcome everyone to today's Synergist webinar, Bulwark FR Town Hall, Your Burning FR Questions Answered. I'm Kay Bechtold, Senior Editor of the Synergist, the magazine of the American Industrial Hygiene Association. I'd like to thank all of our attendees for joining us today, and especially Bulwark for sponsoring today's webinar. Today's presentation was built directly from questions submitted by users of flame-resistant and arc-rated clothing. This webinar will be presented in a Q&A format, but we're going to try to reserve some time at the end of the hour for any new questions our audience may have. I'm pleased to welcome back Derek Singh as today's presenter. Derek has worked for more than 25 years in the flame-resistant clothing industry in a variety of roles, and he has assisted in developing and implementing programs for some of the largest companies worldwide. In his current position as the Technical Training Manager for Bulwark Protection, Derek has developed over 40 hours of training curriculum for Bulwark Institute. These training efforts cover all aspects of flame-resistant and arc-rated clothing. In addition to being a recognized subject matter expert on the proper selection, use, care, and maintenance of FR and AR clothing as secondary PPE, Derek is also a qualified safety sales professional and a certified safety health environmental professional with the International Association of Safety and Health Professionals. And now I'll turn the presentation over to Derek.
Kay, thank you very much for that kind introduction, and thank you to AIHA for having us back again for one of our town halls and our Q&A sessions. So before we get started, a couple things real quick. We're going to go through a number of questions, time permitting, that everybody has submitted on a variety of different cross-sections where flame-resistant and arc-rated clothing factor in. If we're going to try and stop with some time left over for any questions that may be on your mind today, looking for an opportunity to ask a question today. And if we don't get to it, and you've submitted a question, they will be submitted to me and we will get you an answer in short order. So with that, first and foremost, let's get the attorneys out of the way. This presentation is for informational purposes only. Customers of Bulwark Protection are solely responsible for conducting their own hazard risk assessment to identify safety hazards in their work environment. Customers of Bulwark Protection are solely responsible for selecting appropriate garments and protective gear for their employees and ensuring wearers use the garments and protective gear properly in conjunction with the appropriate gloves and footwear. Because working conditions and other factors may vary, Bulwark Protection does not make any representation that these garments and protective gear will protect wearers from injury. So all that stuff's out of the way. So welcome to our town hall. The premise here is we receive, as I said, a lot of questions around FR/AR clothing, and not just on how to properly select, use, care, and maintain clothing for hazards, but also how does it interact in the real world, real case situations, real life challenges for safety professionals in and out in the field. So we did our best to take these questions as they were asked to us. We tried not to really edit the questions or twist the questions to get to a certain answer. We did our best to upload them as they were given to us and answer accordingly. So some definitions to help out. We use crazy amount of acronyms in what we do, and sometimes I forget that these acronyms are not universal and not everybody is as myopic about flame-resistant arc-rated clothing as I am. So FR/AR, just as we've mentioned before, flame-resistant arc-rated garments. Flame-resistant first, why? Because additional testing gets you to arc rating, so flame-resistant first, then arc-rated. Flame-resistant, as it is being defined here for us, this is fabrics that will self-extinguish, do not support combustion, they do not melt, drip, or add to the injury. Arc rating, that's an additional testing once you have a flame-resistant fabric and you want to then elevate it to withstand an arc flash. You do additional testing, so it goes from flame-resistant to arc-rated. All arc-rated fabrics are flame-resistant. Not all flame-resistant fabrics are arc-rated. If we do have any questions in and out today where we're talking about chemical protection from our standpoint as a solution, we only deal with small amounts of inadvertent liquid chemicals at atmospheric pressures. Fancy way of saying we don't build barrier suits, so we don't really talk to that from our perspective. There are questions in here about those type of protections and FR clothing, so we'll address those accordingly. But chemical protection, when we're talking about it, it's a special treatment that goes into the fabric that assists the fabric in repelling small amounts of inadvertent chemical splash. Meltables or non-FR synthetics such as polyester and nylons, they will add to the injury. So when we're talking about meltables, just as you would think those are. So we're often running in the secondary protective apparel world. We protect against short duration thermal events. Where can we find those? In our electrical community, whether you're an electrician, in a low voltage environment, in a facility, or you're in utilities. That's an arc flash hazard. Our flash fire hazard, typically that's our hydrocarbons, our chemicals. We're looking at refineries, oil and gas drilling, and as I mentioned, chemical facilities. Molten metal splash, primarily two of them there that we're focused on, the steel industry and the aluminum industry. Molten steel and molten white metal like aluminum. There are particular fabrics that will shed aluminum splash, and then really in our steel industry we are protecting against some splash, but we're really also protecting against massive amounts of radiant heat there. And then combustible dust is kind of a new emerging market for folks. As we look into that, that is chain reaction flash fires caused by dust, which is in diffuse, in open air, in confinement. A lot of factors go into creating a dust explosion, but they tend to be chain reactions because that explosion obviously releases more dust, more diffuse dust in air, et cetera, et cetera. So that's where you find secondary PPE or shirts, pants, and coveralls that have flame-resistant properties to self-extinguish. Those are the hazards we're looking for. So let's get into the Q&A. Are disposable Tyvek coveralls on top of flame-resistant clothing for contamination control acceptable or not acceptable? Please explain why or why not. So the simple answer is because Tyvek in and of itself has no flame-resistant properties, it is a barrier, and in a thermal environment, it will melt, drip, and add to the injury. The easier answer is no. And even if we talk to our friends at DuPont, who Tyvek is their trademark barrier and most common barrier garment, they will tell you there's another product called Tychem that actually is a barrier and has flame-resistant properties to it. So a couple things to look for here. As you look at the hazard, either eliminate the thermal hazard, so there is no arc flash or flash fire hazard. Then can I put a Tyvek over top of my flame-resistant clothing? In that case, if you've eliminated the hazard, we're talking about the thermal hazard, then yes. If you're working in the hazard, then your outermost layer cannot melt, drip, and add to the injury. It has to have flame-resistant properties, and even better yet, have properties that are for that hazard. A lot of protective soil barriers, any other kind of protective barriers that you would think of putting over to protect your flame-resistant arc-rated PPE are designed, if they do have FR properties, that means they won't melt, drip, they're not going to ignite, but they're not meant as a standalone. They are basically going to, the easiest way to say it is disappear in an arc flash. The thermal energy will evaporate that outer protective layer, then your under layer, your original shirt, pant, or coverall is going to do all the work. Same in a flash fire. We want that outer layer not to catch fire. We want it to not melt and drip and add to the injury, but really what's doing all the work is what you're wearing underneath. So the asterisk there is if you do adopt a soil barrier that has flame-resistant properties, it's not a standalone. What's going to be doing all the work in that thermal hazard is still your shirt, pant, or coverall that you have underneath. I've read that research has shown that air pockets generated by the female form, the female body, when wearing clothing designed for men, leads to increased severity of burns during an incident. Is this true? Well, in actuality, that air gap is providing some insulative properties and adding to the protection. In fact, our standards talk to making sure that our flame-resistant clothing is not too loose fitting, is not too tight. We want to have some loose fitting to enhance the thermal insulation from those air gaps. It's also repeated in 2113, which is our go-to, which is our playbook for the flash fire hazard. It also talks about having some looseness to our fitting so that we maximize the air gap. What the question may be alluding to is that there are incidents when our female employees have been injured, maybe worse than the male employees in the same hazard wearing the same PPE. It's primarily due to the undergarments. Remember, and we'll talk about more of this in some of the other questions, natural fibers, no metal, no wirings, and nothing that's meltable. So there may have been some allusion to that. How does laundering the FR clothing affect the FR AR properties, specifically if fabric softeners are used? So in this particular case, we're going to kind of answer this in two phases. First and foremost, proper laundering of proven products utilizing proven supply chain partners has no diminishing effect on the ability of that garment to self-extinguish and minimize injury. So let's reverse engineer that answer a little bit. We are talking about following the manufacturer's guidelines, which all the standards talk to, whether you're looking at 70E, 1506, or 2113, they all tell you to follow the manufacturer's guidelines in proper cleaning process. These are proven products. These are garments that are made with fabrics that have been in the supply chain and been in the sales cycle for a while. Or if they are new, you are utilizing a proven supply chain partner that has a legacy of developing innovative products, aka new products, into the marketplace that meet or exceed any minimum standards. So we are looking to avoid low-cost leaders. We're looking to avoid offshore products. We're looking to avoid fabrics of questionable origin, any kind of questionable standards or things that may have come in. That's the first part of the question. The last part of the question is in and around fabric softener. All manufacturers recommend not using fabric softeners either in the liquid form or in the dryer sheet form. Typically, these are some form of petrochemically based product, and the accumulation over time can affect the FR performance during a thermal exposure. Regardless of how that FR engineering is going to work, whether it's a fabric-based, fiber-based, or molecular-based, you're going to impede that or mask it, and it's going to not work as well or protect you as well as it could in that event. So, best case, don't do it. If you happen to accidentally do it or are unsure if it happened, just rewash it without, and you will flush that fabric softener out of that garment. What is the expected lifespan of FR, and how does one know that it has reached the end of its life? Very good question, because it's not an easy answer. You're going to have to default to manufacturer's guidelines, proper laundering of proven products, utilizing proven supply chain partners, again, has no diminishing effect on the ability of that garment to self-extinguish and minimize injury over the life of the garment if you're taking care of it correctly. How do you know? The tough thing is you don't. FR, unless you need to use it, is unseen. FR, those flame-resistant properties in that shirt, pant, or coverall, it looks like a shirt, pant, or coverall until you need it to do what it does. So when we look at where it is sourced, where are the fabrics sourced, what is the legacy of the supply chain, and what is the legacy of the manufacturer, and what can they bring to bear to make sure these things meet your satisfaction as far as whatever that criteria is. Look for what the guarantees are. I can only speak to our products here, so that's why it's my manufacturing guarantee that's up there that talks to what the life of that garment is. Other top quality in that proven products, in that proven supply chain will have language that is similar, and that's ultimately where you have to take your confidence is where and how these are getting done. Do the undergarments worn under FR clothing affect the FR's effectiveness in preventing burns? Talking typically here, T-shirts specifically. No, maybe, and yes. Why is the answer such? Because it says T-shirt specifically, it doesn't tell me what fabric content that T-shirt is. Non-FR fabrics worn under FR garments can contribute to serious injury. They may be able to minimize injury to a point or increase protection and maximize benefit and minimize injury. How is that possible? It's all dependent on what that fabric content is of that undergarment. Is it a synthetic? Is it a natural fiber? Or does it have flame-resistant properties? Three completely different outcomes from the same T-shirt. In the synthetic case, non-FR synthetics such as polyesters and nylons will add to the injury. That's our athletic performance wear. I don't need to tell you the brands. You all know the brands. They're highly touted. They're great at the gym. They're great on the athletic field. They're great on the weekends. Nowhere near our work environment if we have thermal hazards. Your outside layer will do its job perfectly. All that radiant heat and IR will melt that 3.5 ounce light polyester to your body and cause significant injuries. Natural fibers like cotton, silk, and wool will provide additional protection up until the outermost layer fails and it's exposed to thermal energy. Does the outer layer fail? Absolutely. You have an arc-rated garment that's designed to insulate and protect you up to a certain arc rating, typically single digits, 8.6, 8.7, 8.9 calories per centimeter squared. Any electricians on the call, any folks who understand working on electrical equipment, when we give you a incident energy, it's depending on how far away you are from the equipment. It is also dependent on that equipment working perfectly as designed, so that is what I put in the calculations. When I tell you that you have 6 calories of incident energy, potentially if that box fails, and I'm wearing an 8-calorie arc-rated shirt, I am technically protected appropriately. Now, if I lean in closer than 18 inches, what's my arc rating? What's my incident energy I'm exposed to? You don't know. What if that machine was calculated at 2-cycle closing time and it goes to 6 cycles? How much incident energy am I exposed to? You don't know. That outer layer now is going to be challenged. If it has more incident energy than it can withstand, it will start to break open. It will start to go away. How much residual energy is left over and you're wearing a lightweight cotton T-shirt underneath, could you have an ignition? That's why we say it is insulative and protective up until it's not. So we've covered no, we've covered maybe. So what is the yes on that T-shirt? Have have flame-resistant properties in your base layers, and they make them. And when you look at good, better, and best, don't wear anything underneath your flame-resistant arc-rated shirt. Wear a natural garment underneath your flame-resistant arc-rated shirt, And for best, wear a undergarment that has flame-resistant properties. If that outer layer begins to break open or fail, you have additional layer of protection, and it's not constituted of fibers that may cause you injury, either through ignition or melting. What's the solution for hand protection if the risks are flash fire and chemical splash? Are disposable nitrile gloves over carbon fiber gloves a good solution? We're answering this even though I will say that gloves are not our specialty. We are shirts, pants, and coveralls, but in talking to some of our glove folks that we partner with and have relationships with, many chemical-proven gloves are meltable and a thermal hazard and should not be worn. And now you may be, based on the question, you may be saying, but hold it on, that the meltable is not underneath the glove, it's on top of the glove, so it's providing some protection. But in a thermal event, you don't know how that shrinkage may happen. You don't know where that outer layer, because it's going to melt, it doesn't have FR properties, it's going to mask the ability as it melts to that flame-resistant glove underneath. It is just not a recommended partnership, and you should look to gloves that have FR properties and chemical-resistant properties. It's not something that nitrile meltable, even though you have a FR component underneath, that melting on that outer layer is going to cause that glove to perform less than it could because it's melting into it and not letting its flame-resistant properties be maximized. We have flame-resistant shirts that we have been told do not have to be tucked in. Is this true? I'm not sure how this question originated. It's an interesting concept. I'm not sure if it's somewhat self-serving. Either the safety person got told by the wearers that this was allowed, or there was a miscommunication somewhere, because none of the standards, whether it's ASTM 1506, whether it's NFPA 70E, or it's NFPA 2113, allow for shirts to be untucked. Why is that? Thermal energy rises. An arc flash does not follow a straight and perpendicular path to the ground. If I'm looking at a 200 amp disconnect, a 480 panel, it does not mean it will come straight out. Most of our hydrocarbon combustible ignitables are heavier than air, so they are by default already at ground level. When they ignite, or that arc flash goes from that box down to the concrete and mushrooms, all that thermal energy goes up. It will take that loose garment and it will blouse it, meaning that the garment will be forced away from the body. All that heat will then go up underneath our garment, and if we happen to be wearing either our birthday suit or our lightweight natural fiber cotton t-shirt that the standard says we can wear, we have now introduced a thermal energy into something that is potentially can be damaged, aka us. It's going to cause damage to our skin that it didn't need to if it was deployed properly, or it's going to ignite our lightweight cotton t-shirt, and we're going to have a fire underneath our flame-resistant clothing. And it does happen, and it does happen to the point that we call it the chimney effect. You're burning inside your flame-resistant clothing. That's why all our standards that you see listed on your screen talk to specifically how to properly interface with your garments, and a shirt and pant are designed to be interfaced by being tucked in. 70E tells you you must have them fastened at the wrist, buttoned to the neck, and tucked in, as does 21.3. When a shirt and a pair of trousers, both flame resistant, are worn together, the shirt shall be tucked in. Remember, these standards are written by people who have seen these things happen, and they are giving you the proper way to wear garments to what? Minimize injury. What are common meltable fabrics that are worn underneath FR? What should they wear under FR/AR instead of those meltable fabrics, or should they wear anything? So you've already seen, as leading up to this question, most of you already on the webinar are going, that's an easy answer. We all know what the meltables are. We know what the common athletic performance gear brands are. We've all seen or even worn what those lightweight synthetics compression garments can do. And because of this format, we don't have the ability to show you some of these horrific injuries, but we have pictures of folks whose flame-resistant arc-rated outerwear perform perfectly, shirt, coverall, and we've seen horrific scarring and horrific burn injuries from those meltables underneath. So what should you wear? All the standards allow for natural fibers. What's that? That's cotton, wool, silk, as they can insulate and, as we discussed, protect as long as that outer layer doesn't break open. To increase protection, adding a lightweight FR/AR base layer will help. And here's a couple things to think about. As a safety professionals, and as I look to my team, whether my team is electricians who are going forth to voltage test, troubleshoot, and verify and keep all the lights on, or my team is involved in oil and gas, refining, or chemicals and have flash fire hazards, I look at my team in the morning and I see, just for discussion purposes, I see a sea of white V's coming from the neck of where they have buttoned up their garments to the neck, and what I see underneath are all the little white V's from our 100% cotton t-shirts. Why 100% cotton? Because I've trained my team. We've had these discussions. They've signed off that they understand, and all of them are going to wear white cotton t-shirts underneath their flame-resistant arc-rated clothing. And I can visually see white. The problem there is what? Can I get a white t-shirt that is 80-20, 50-50, 60-40, or let's pick a whole bunch of other ratios? Can my team inadvertently have meltables underneath because of the composition of that white V that I see? I have no idea that everybody on my team, even though I visually see that white V, isn't 100% cotton. The other factor is, for that visual test, is all the manufacturers of lightweight base layers today that have FR properties have all went with a really common sense little visual cue to give you some peace of mind. Their logo is going to sit right where that little V would be, and that logo is going to be a Bulwark triangle, a Carhartt FRC, a dragon for Dragonfire, NSA's got a nice little logo. All the manufacturers in that proven supply chain that we've talked about that do base layers have put a logo there, so I don't have to look for white. I can just look for the logo of our approved specified brand of fabric that's in there to give additional protection to our people who are in thermal hazards. Do you feel that the color of FRC has a large impact on the wearer's heat levels when working in an outside environment? Do you recommend light or dark? I have talked to people in the field and they prefer dark due to any oil or other stains that they may get. So as with the majority of PPE, striking a balance for employers is key. In the case of garments in high soil environments, you don't want to invest thousands and tens of thousands of dollars in light colored FR that's only going to become stained over time because of the high soil, the wear and tear. So lighter colors may create an undesirable image versus darker colors in the same environment. Yet darker colors, as we all know, retain more heat than their light colored versions. While OSHA currently offers guidelines and endorses NIOSH's criteria for a recommended standard, it has no enforceable rules per se. Both OSHA and NIOSH respond similarly whenever possible, wear loose-fitting, light-colored clothing. Loose-fitting for good airflow. Remember when we talked about the additional insulative components? Notice they say light color, not necessarily lightweight, and we'll talk about that in a couple slides. Because why? Weight's not really a significant factor in breathable single-layer garments when it comes to heat stress. So what's the balance? Maybe there's areas, for example, we do have what's called color block. You're seeing a lot of lightweight on the top, large majority of the body. Then you're seeing color block with navy or gray around those belly areas where people tend to rub up against stuff when they're carrying things. We're seeing color blocks on the forearms as we're carrying and we're moving and we're wrapping. So there are design functionalities that can help offset some of that. Hey, I still want to be in a light color garment, but hey, I have soil conditions that I have to balance. So maybe it's not a khaki, maybe it's a light blue. Maybe it is a khaki versus a navy. There has to be some balance, and that's definitely a challenge. As we do know, when working in hot environments, maybe I have a summer coverall or a summer shirt, and then we're minimizing the wear and tear because we have seasonal shirts, pants, and coveralls in certain areas. You may have to get creative. There may have to be some offset of cost to get through that. It's not an easy fix. When you start looking at some of these real-world scenarios, it's really easy for manufacturers and salespeople to say, just do this. And I go, well, if I just do that, it's not going to work across my whole employee set, my whole employee conditions, and my whole employee environment. It may take a number of different solutions to get through that. If I wear a cotton shirt and an arc-rated jacket over that, do I have to tuck in my shirt or jacket? Well, the easy answer is no. But my bigger question is, why are you not utilizing an arc-rated shirt under your arc-rated jacket? If you're wearing a cotton t-shirt underneath your arc-rated jacket thinking that you're protected, you'd be wrong. You're going to stretch, you're going to move, you're going to unzip as you get hotter. You're exposing that flammable material to potential thermal energy all day long if that's the configuration you're looking to protect you. What if you take off your jacket and you don't think, you make a mistake, it's getting too hot, I'm sweating, now I take my jacket off. There are too many variables in the above question to consider this a sound practice. You're really jeopardizing all the investment that you've made because, one, those jackets aren't cheap. So I know that if you have a ARC-rated jacket program, you have provided people with ARC-rated shirts, pants, and coveralls, and there's been a tweaking of the rules in order to get to this question. Don't do it. There's just too many gaps in that configuration. In attempting to keep my flame-resistant garment uniforms clean and non-absorbent in flammable liquid or flammable waste-based processes or process safety management applications, do you recommend any particular type of FR as an outer layer? So this kind of dovetails off a previous question. And as we said, many single-use garments for soil protection are flammable and should not be worn. So what can I do now to ensure compliance? First and foremost, determine what your hazards are present, such as thermal and chemical. Disposable garments provide warnings, as we talked about, to only be used as over primary protection because that shirt, pant, and coverall is still going to go all the work. And then the key is to strictly combine your FR/AR shirt and pant or coverall with lightweight disposable garments that have flame-resistant chemical protection properties or other properties that are necessary. Bottom line is these lightweight disposable coveralls are designed not to catch fire, not to melt, not to drip, hence not to add the injury. There's not a lot of substance there to do any kind of protection. All the protection is going to be from that shirt, pant, or coverall underneath. There's a link here to provide some additional guidance to looking at in and around these garments for soil protection, these garments for inadvertent splash from either whatever process you're utilizing throughout your facility. And if we need to get more specific in that, obviously my email will be here at the end, and we can definitely dig into it more in detail as it gets to your specific site. Discuss heat stress garments, including those that could be worn under FR/AR clothing, heat stress, and layering. That is a broad question. We do provide, in fact, there's a whole webinar, a whole 45 minutes that we just talk about heat stress and garments and what we have to do there. So this is a balance. It is a challenge, and additional questions we'll talk about it because it's, pardon the pun, a hot topic. There's a balance that manufacturers must work with. Lightweight, open weave, moisture wicking. As all three factor into comfort, factor into how well you can work in hot environments. So if I need to have more of something, okay, that's going to be counterproductive to comfort, I need to beef up in another area. So for example, everybody talks about lightweight. Weight has no bearance on how hot you're going to be. In fact, NIOSH and obviously OSHA take the same stance that single layer fabrics, whether they are non-FR or FR, are very, very low contributors to heat stress. Your wet bulb studies have zero indicator or multiplier to single layer fabric. Where we get into trouble is when we introduce barriers like chemical protection, when we introduce multiple layers like arc flash suits, when we are going above and beyond that single layer, yes, then what you're wearing does factor in. What we're talking about here is how can we get to comfortable in this balance. I need some weight, okay, to protect you in a thermal event. The fabric is doing all the work. The fabric has the job of protecting you. So if I have to give more substance there to insulate and protect you against all this heat and all this energy, then I want to open up the weave a little bit more. Then I want to have moisture wicking that is part and a characteristic of the fabric, not just a finish that I've put on the garment that's going to wear out. I want to combine hydrophobic, hydrophilic fibers that are working in tandem to remove moisture from your body, to give you the feeling of dryness, which makes you cooler and counteracts any kind of additional weight that I may have put in there, because the perception is across all workers, the heavier it is, the more uncomfortable it's going to be, even though comfort in and of itself is completely subjective. If you don't believe that, next time you have a team meeting and the ambient air temperature in your building where you're having the meeting is 68 degrees, just take a look across your team and how they're dressed. Short sleeve polo, long sleeve t-shirt and sweatshirt, t-shirt and hoodie, jackets. There'll be a variety, and I'm going to assume since they all showed up there in that way of dress that they're going to be somewhat comfortable. So comfort in and of itself is subjective. How we manage our body's metabolic rate in heat and cold is a combination of the fabric weight, what kind of weave we have, and what kind of moisture wicking capabilities we have when it comes to sweating. Because once we're over 98.6 degrees, all the other mechanisms for cooling us down are gone, and all we have left is our sweat capability. And the more efficient I can make that in the combination of these three is ultimately what's going to provide me a more comfortable experience. So what options of lightweight FR clothing are there today? Well, the more options today than ever before. They're utilizing a variety of fiber combinations. We mentioned hydrophobic and hydrophilic, synthetic and natural fibers to help repel and absorb water in tandem in that fiber matrix to give you the best wearing experience. As I said, there's a number of levers that manufacturers can use to influence comfort. Even though fabric weight is much less measurable contributor than the other factors, aka open weave, I can measure how much volume of air passes through a fabric. Moisture wicking, I can actually measure moisture vapor transfer. How well can a fabric move moisture through it as I can, as opposed to weight. Weight is very, very difficult, and really, when it comes to it, other than a perception, is a non-contributing factor. So all the time, manufacturers are first and foremost challenged with providing a necessary protection. So I have to protect you first and foremost. If you have a thermal event, if I can't protect you, it doesn't matter what any other characteristics I bring to bear on the garment. So first and foremost, we protect you. Then we look to fine-tune everything else. So are there new breathable material options? We are working, and when I say we, it's the big collective we. It's we as a marketplace working for you, our end user customers. All manufacturers with arc-rate and flavor-resistant fabrics have been on a quest for the last 25 years to develop new fiber combinations in the best ratios to take advantage of all their positives and minimize all their negatives. We've looked to partner with fiber and fabric developers in different innovative areas to try and capture some of those new products. I even bring to bear some that you may already recognize: Glenguard and their featherweight fabrics, Milliken's DH, their dual hazard, which is both arc flash and flash fire and lightweight, Tenkata's new Evolve fabric, and DuPont's new Nomex Comfort. All of these are working in that realm to get you something that's more breathable, more comfortable. And if it's more breathable, more comfortable, you're more likely to wear it. Hence, we're going to have a higher compliance rate. And if there happens to be an incident, you're going to be better protected. With that reminder, big red letters, the single fiber characteristics listed below in and of themselves do not relate to comfort. Comfort is purely subjective. If all I have on my marketing brochure is it's lightweight, doesn't mean a whole lot to me. Why? Because I've had to take that weave and I've had to tighten it up so tight, because if I'm sitting at 5.5 ounces and I'm going to protect you against an 8-calorie arc, I'm going to have the tightest weave possible, because there's not a lot of fabric there to protect you. Moisture wicking in and of itself, that's great, but where is it when it comes to the combination of lightweight, moisture wicking, and air permeability? Air permeability sounds great in and of itself, fantastic. A screen door is highly air permeable, would be the most uncomfortable garment you could possibly wear. So everything here has to get done in balance, and as a marketplace, they're working diligently to provide you the best product as we can. So taking a quick look in time here, a couple more of the formal questions, and then we're going to break into, and I'm going to see if Kay has any questions that you all may want to get answered today. So if you're thinking of anything, or if this has brought anything up that's site-specific to you, go ahead and type that in. Kay will moderate those for us. We'll answer a couple more here of the scripted ones, and then we'll go to you, the audience, and see how that goes. So any problem using the pest control chemical DEET on FRC? Hopefully most of you on the call today, this is an easy one. You've already answered it yourself. You've said no. Why? DEET has a very, very low flash point. It's about 300 degrees, and for us sitting in around doing non-thermal hazard-related stuff, not a big deal. For those of us that are in a thermal hazard, when we're talking about arc flashes and flash fires, flash fire 1,500 to 2,000 degrees, I easily get to that flash point. Arc flashes outside that box, 5,000 to 8,000 degrees, I easily get to that flash point. So what you'll have is DEET-saturated clothing that is going to ignite, and you're going to have tons of after flame hurting you unnecessarily. So don't do it. So what are my alternatives? There's a couple things. Permethrin-based products on garments. So additional trading is needed. Permethrin-based products are, for the most part, traditionally safe for flame-resistant clothing. The caveat is if you're going to spray it, clothing only. Don't be wearing your clothing when you're spraying permethrin-based products on you, okay? Take your gear, throw it down on the back of the truck bed, throw it down in the carport in the morning, give it a quick spray there, flip it over, spray it again, let it dry before you put it on. There's other ones. If you go into that Google box, I'm sure you all have the internet because you're listening to us today. Google in non-DEET insect repellent, FR safe insect repellents. There's a number of them that come up there. Make sure you do your due diligence. It is up to the manufacturer of that product to provide you the test data across the fabrics that you're going to be wearing to let you know that it's safe. It's in this, where we are today, it's not the manufacturer of the garments process, it's the actual manufacturer of the insect repellent that's going to have to provide you that level of comfort. Do the fibers with added fire retardant have the potential to be absorbed by the skin of the wearer, assuming the fabric is not used until the fibers have been cured? Does the fire retardant have the potential to be absorbed by the skin? Really good question, especially when you're talking about a variety of FR engineering utilized not just in North America, but really with a global economy and the ability to reach out and access fabrics across the world made in different areas with different rules and different guidelines. We go back to that term that you've heard me use multiple times. The answer is no. The asterisk is when utilizing market-proven products from market-proven supply chains. Look for legacy fabrics purchased across multiple sales cycles. Within North America, you know right off the top of your head, if you've been involved in providing garments for your folks for any sales cycles, you know who the top fabric manufacturers are and what those brand names are. Don't get confused by the terms inherent and treated today. Back when I started, back in the late 80s, early 90s, you had inherent and treated. Why? We had 4 or 5 fabrics utilizing really 2 ways of getting that FR engineering. You had a fabric that by definition was a fuel. You put it through a process. You added fire retardant chemistry to it, and now you had an FR fabric. You had fibers that we changed at the molecular level. You took nylon, you turned it into FR nylon because you tweaked the molecular formula so it wouldn't support combustion. You went from FR nylon to Nomex or Kermel or other brand names as such. In today's world, we are taking inherent, what would be called inherent fibers, and we're weaving them with natural fibers that may or may not have FR engineering, and then we're cross-sectioning those with others. Going back to a couple of questions earlier, we're taking all the pros of all the fibers and we're trying to weave them into a fabric that minimizes the cons and increases the pros to give you the best benefit. So look for proven supply chain partners that are top on innovation. They're investing in innovation, and more importantly, they are verifying any of the test results of the fabrics that they are sourcing to exceed any of the standards that we have today for flame-resistant arc-rated clothing. Because remember, standards are a minimum. I have to get to here in order to do X. We want to make sure that we're pushing beyond that. So really know your supply chain. So with that, we're going to get into some here. We're kind of repeating a little bit. I want to turn it over to Kay and ask Kay if we have any questions that have come in that are best to answer here in the last 10 minutes or so that we have left.
Great. Thanks, Derek. We do have one question so far. Just as a reminder to the audience, if you'd like to ask a question, please type it into the chat window on the right side of your screen and send it to all panelists. One more reminder is that in case we run out of time to address all questions, we'll be sure to pass them all on to Derek, who will be able to answer them outside of the webcast. Derek, the first question I have is from Thomas, who asks, are there any specific FR selection tools that you would recommend?
It's a good question because I don't know of anything to where you have, I mean, I went through a mortgage calculator. I went through my car loan calculator. I don't think there's anything as simple as where we can plug in what our hazard is, what my people are against, and we can split out a couple of options for you. What I recommend is taking a look at your safety channel that you have already. They are probably already plugged into a number of top suppliers when it comes to flame-resistant arc-rated clothing. Get in contact with them. Make sure that whoever you're talking to from a business development standpoint has a number of years in the fabric. You would consider them, and you can figure out real quick if they know what they're talking about from a subject matter expert standpoint, that they're more than willing to talk about what their products do, but also in general where the marketplace is going, where the trends are happening, and are able to, and this is the biggest thing, they're able to fund a wear trial for your team. Whether that's a team of 1,000 and we have 10 guys, or if that's a team of 10 and we have 2 or 3 guys, get them in different shirts, pants, combinations. Not everything is going to work for everybody. The easiest thing for compliance is to give people a choice. There are great companies out there that use a number of different proven FR providers that can provide you that choice. So really, put together a team, get 2 or 3 folks in the door, invest some time. It will pay dividends in the end, and get clothing on your people's backs, and then just verify that whatever they're picking is going to meet or exceed whatever your hazard requirements and the standards are for your hazard.
Okay, great. Thanks. The next question I have has a little bit of an explanation too. Says, our garment service brought back a couple of our FR garments that were repaired with iron-on patches. They also had reinforcing stitching. Is this an acceptable method of repair, or should we ask for a new garment?
Interesting. So the real key there is there's a couple things that have happened in the industry. They do have flame-resistant fabrics that you have the ability to iron on. Others are going to stitch on. There's 2 key things that you have to look at. First and foremost, what is the fabric that the iron-on constitutes? Is it the same as my garment? All the standards will tell you if you are going to make a repair, like materials and FR thread. The only areas in a garment that you don't have to have FR thread is when you hem them, or when you are stitching on a emblem, traditional, what our industrial laundries call R1, R2. Those are your garage-looking emblems, the larger company emblem, the small Dave name emblem. Those can be non-FR, and those can also be put on with non-FR thread. For repairs, they have to be like materials and FR thread. So if they're iron-ons, it has to be, if I have a Nomex garment, it has to be made of Nomex fabric. If I have a TechaSafe Plus, it has to be TechaSafe Plus. I can't use Nomex on TechaSafe Plus and vice versa. So you have to know that. Secondly, I'd be very cautious. There are no standards that say how many repairs in a garment before the garment needs to be replaced. I personally don't like repairing garments. One, that's a safety device. That's a life-saving piece of equipment that I have just the integrity of it has been broken. If we're going to say that's unreasonable, we can't be replacing every garment that gets a rip or tear, then my rule of thumb, because there are no guidelines in the standards, is 3 inches and a nickel and 1 of each. I can have 1 hole the size of a nickel that I'll repair, and I can have 1 rip or tear that's 3 inches of length or less that I can repair. Any more than that on my life-saving piece of equipment, I want it replaced. I want my marketplace thinking of their FR clothing the same way they think of their fall harness. Everybody that wears a fall harness doesn't necessarily fall. Many people wear fall harnesses throughout their career and have never had to use them. The same goes with my flame-resistant arc-rated clothing. You wear it every day. I hope you never have to use it for what I built it for. But if you do, it has to be in good condition, in good repair, and worn properly in order to save your life. Does that sound similar to your fall harness? It has to be in good repair, no rips, tears, cuts, or frays. It has to be worn properly, and you have to be trained on it. Exact same scenario. You don't allow rips, tears, and frays on your fall harness. Please don't allow it on your flame-resistant arc-rated clothing. But if you must, like material and FR thread is all you're allowed to repair it with. And please institute a program where you're going to monitor how many of those holes and how many tears you're going to tolerate on your life-saving piece of equipment before you demand that it gets replaced.
Okay, great. Thanks, Derek. My next question I have is, how can we know whether a product is proven?
We kind of alluded to it a little bit early on. FR is unseen. In fact, if I take 10 manufacturers and half of them are non-FR and half of them are FR, and I take all the identifiers, all the logos off of them, and I put them on models, and I walk them around the room, and those are navy blue coveralls. I've been in the business 25 years. I'd have a tough time telling at a distance. And more than likely, most people would have a tough time telling which ones have flame-resistant properties. Unfortunately, you don't know how well that FR engineering is done. You don't know how durable that FR engineering is until you need it. So at the end of that thermal event, arc flash or flash fire, you'll be able to tell how well your flame-resistant arc-rated coverall shirt or pant worked. We don't want that. So what I say is go back to your supply chain. As you would look through and evaluate, look for proven players in the field, look for those who have a legacy, aka, do you build FR? Yes, all we've ever done is build FR. How long have you been building FR? 40 plus years now. Show me some of your innovation. What are your steps? How do you verify, and how do you verify what the manufacturers are telling you, or do you just take the manufacturer at their word and their so there's different criteria you can build and put together a very simple checklist, and you will easily have a half a dozen suitors to fulfill that proven product. You have to be cautious. Does it matter where it comes from? Absolutely. Meeting of standards. Standards are very minimal. Standards are great, but in our business, it depends on launderings, it depends on testings, and in order to deal with the laws of economics, I launder 100 times for 2112. I launder 25 times for ASTM 1506. I launder 3 times to give you an arc rating. You potentially can outwear all the current testing protocol for your flame-resistant arc-rated clothing. So that being said, if you go beyond the test protocol, what's left? What's left is that proven supply chain to where they are guaranteeing that those garments are going to be durable, and their guarantee means something.
Okay, great. Thanks, Derek. Unfortunately, that's all the time we have for today, but we'll be sure to pass any additional questions along to you to answer outside of this hour. My thanks to Derek Singh for your presentation, to Bulwark for sponsoring today's webinar, and to all of our participants. Please keep an eye on aiha.webvent.tv for future Synergist webinars, and hope you all have a great rest of your day.
All right. Thank you, everyone. This actually concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webvent.tv. We will send all registrants an email tomorrow with this link. And please visit our event calendar to sign up for future webcasts.